Okay, so I lied. There's one more part. So this is our last example. And this time it looks at a half-life question. And again, we looked at this last year. We had to solve for an exponent, but you had to do trial and error to solve for the exponent then. So here's the example. Idris works in a laboratory that uses radioactive substances. The laboratory received the shipment of 200 grams of radioactive radon, and 16 days later, 12.5 grams of the radon remained. Determine the half-life of radon. Okay, so let's take a look at the information we know. We know how long it took. So that's the time value. We know how much radon we started with. So that was our initial mass of radon, which we call m naught. Okay, and we know the final mass. We know the mass that remained at the end of the 16 days, which is 12.5 grams of radon. And so here's the little hint that we have here. This is the half-life formula that we looked at last year. And so we know that we have m of t, which was 12.5 grams. We know m naught, which is 200 grams. We know t, and the last thing left to solve for is the denominator in the exponent, which is h. So let's plug in the information we know and let's see what we can do from there. So m of t is 12.5 equals 200 times a half of 16 over h. Okay, now again, I can't take a logarithm of both sides yet, and that's because I have a coefficient in front of the power. So I need to get rid of this coefficient first. And again, because the operation between the coefficient and the power part is multiplication, I'm going to divide both sides by 200 to get rid of it. And I get 1/2 to the exponent, 16 over h, is equal to 12.5 divided by 200, which is 0.0625. And if we actually reduce this, this actually gives us 1 over 16. So we'll talk about that later. Okay? And so what I'm left with is 0.0625 equals 1/2 to the exponent 16 over h. Now, in order to get the exponent part, which is what I'm looking for, back into a place where I can actually solve for it, what I need to do is take the logarithm of both sides. So I'm going to take the log of the left side and of the right side. And so what I end up having is log of 0.0625 equals log of 1/2 to the exponent 16 over h. And I know that using the power law of logarithms, the exponent in a logarithm can be written as the coefficient of the logarithm. And so I can rewrite this as log of 0.0625 equals 16 over h times the log of 1/2. Now again, both of these logarithm parts only have numbers to them, and so I can isolate the coefficient here, which is 16 over h, by looking at dividing log of 1/2 on both sides. So I'll do that in a different color so you can see what I'm doing. So I'm dividing both sides by log of 1/2 to eliminate it from the right-hand side. And so on the left-hand side, I can evaluate that on the calculator, but on the right-hand side, I'm left with 16 over h. So I'm going to use the calculator to evaluate the left-hand side first. So I have the log of 0.0625, and I'm going to divide that by the log of 1/2. And I get a result of 4. That's a pretty nice number. And so I can cross multiply to help me solve for the value of h. So I have 4h is equal to 16, which means h is equal to 4. So what that means is the half-life of radon is 4 days. Now, if I look back at the problem, and at this step here, where we had log of, 12.5 divided by 200, I could have actually looked at this slightly differently, and I could have actually looked at this problem as a reduced form of a fraction. So on the right hand side, what I was left with is 1/2 to the exponent 16 over h. And on the left hand side, I could have actually reduced this and I would have gotten 1 over 16. And so if I did this like I would have solved this last year, I could have actually rewritten 1 over 16 as a base of 2. As a base of 1/2. And that's pretty straightforward because the denominators are values that can be written with the base of 2. And so instead of writing 16, I could have rewritten this as 1 over 2 to the exponent 4 equals 1 over 2 to the exponent 16 over h. And so this is the same thing as writing 1/2 to the exponent 4 equals 1/2 to the exponent 16 over h. And so because the bases are the same, I know that the exponents must be equal to each other. And so I get the same thing as what I had before. And if I solve this, I have 4h equals 16, which means h is equal to 4. So even without using logarithms, I was able to solve the same problem just using the exponents that we looked at last year. Okay? And that's the end of it. So your home fund is to complete. Well, again, this is your school fund, no longer your home fund since you will be doing this at school. You're completing page 346 to 348. Those question numbers. Don't forget to watch the video for lesson 5 for tomorrow night so that you're ready to do your homework in class again. Take care.